What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Question 3.109 in the textbook says for this gate, theta equals 45 degrees, y1 equals 3 feet, and y2 equals 6 feet. Will the gate fall or stay in position under the action of the hydrostatic and gravity forces if the gate itself weighs 18,000 pounds and is 3 feet wide? Assume the temperature equals 50 degrees Fahrenheit. Use calculations to justify your answer. First things first, let's figure out our goal here. Alright, our goal is to determine if the gate will fall or stay in place. So this gate right here. So it's saying if this water, if it has enough pressure force, and that can actually push this gate over. Givens, given a lot here. So we're given, I just read it here. So this is 45 degrees. Y1 is 3 feet. Y2 is 6 feet. The gate weighs, so weight of gate equals 18,000 pounds. The width of gate equals 3 feet. The temperature, I'll write it over here. Temperature is equal to 50 degrees Fahrenheit. We're gonna need to know a specific weight of the water per usual. So we gotta convert this to Celsius, or maybe we don't. Maybe does the textbook give it to us in Fahrenheit? Oh, it does. Yeah. Okay. Oh, I see what happens though. Okay. I think we do everything. Yeah, so it does give it to us. So at 50 degrees Fahrenheit, the specific weight is 62.4. So we don't need to convert it. Everything's in feet and such, so that'd be stupid. So the specific weight of water, what do we say equals? 62.4 L pounds force divided by feet cubed. Okay. So with these gate questions, you can break it down into 3 steps. Anytime you see will a gate fall, or like finding a force and there's a gate involved, just anything like that, you're going to want to use these 3 steps. So first step is find pressure force acting on the gate, and then you will want, the next step is to locate center of pressure, the center of pressure of the gate, and then the next step would be to calculate the moment about the hinge to find, and that'll be your last step. So let's put moment about hinge. So those are our 3 steps, so let's get started with it. Step 1. So this is step 1. We gotta find the pressure force. We know that the equation for pressure force is pressure times area with respect to the centroid of whatever we're trying to find. In this case, it's our gate, our rectangular gate. We know we can rewrite that specific weight times height from the surface of the water to the centroid of the gate. And then we just keep that area, and I'll put area of the gate. Okay, so I'm going to put a W, specific weight for water. So we already know the specific weight of water. We don't know the height yet, so let's solve for that. The height, it's a rectangle, so we know that the centroid of the gate will just be halfway. So we'll go down 3 feet, and then we go down 6 feet all the way to the bottom. The Y2 starts at the beginning of the gate and goes to the bottom, so we can just half this, and we know that the centroid is going to be at this Y2, half of that, so 3 feet. So it'll be 3 feet plus 6 feet divided by 2, which equals 6 feet, right? So that's our Z value. Area of the gate, it's a rectangle, so just length times width. We need to find length though. We know that we're given the width, right? So the width says 3 feet wide. But we need to find the length. So to do that, we have to draw a triangle and use our trigonometry skills here. So this is the gate. That's not very good. This is the gate, and then we're trying to find the length of this, so trying to find the length of the gate. We know the height, we know this value right here, that's 6 feet, right, that's that. And then we know this angle is 45 degrees. So we can do, using our trig skills, we can do, say, sine of 45 degrees. So that's opposite over hypotenuse. Rearrange it, give us L equals 6 over sine of 45, and sine of 45 is 1/2, I believe. No, I don't know. But anyways, if you do that, you will get the length of 8.485 feet. So 6 over sine of 45 degrees gives you the length of a gate, 8.485 feet. So let's plug these values in that we just solved. The length is 8.485 feet, and then the width is 3 feet. So now we know the area of the gate is equal to 25.96 feet. Okay. I'll make sure of that. It's 25.45, not 9. Okay. So we have everything we need to know to solve for the pressure or force now. Specific weight of water is 62.4 lbf, or pounds force per feet cubed. The height is 6 feet to the centroid. Area of the gate is 25.45. I'm gonna put 46 if you round it. Okay, and then that gives us a pressure force of 95.32 pounds force. So first step completed. And on to the next step, we gotta locate the center of pressure of the gate. So to do that, we have to use this formula. Slant distance of the center of pressure equals slant distance from the centroid of the surface of water plus area of moment of inertia, area of gate, which we already solved, times slant distance again. So to solve this, we're given a formula this, we can solve for that. So let's go with that real quick, the area moment of inertia. It says in the textbook that the area of moment of inertia for a rectangle is base times height cubed over 12. So in this case, that is, the base is 3 feet. So the base of 3 feet is the that width that we were given, and then we know that the height is, we saw for it, is 8.485 feet cubed. Yeah, and the height is that because it's just the length of the gate, right? So that's why I said we already solved for it. So the height, the length of the gate, same thing. And you divide that by 12, and you get the area moment of inertia is 152.7 feet to the fourth. So we solved for that. We solved for the area of gate already. Now we're going to find the slant distance from the centroid of the gate to the surface of the water. So let's draw a triangle again. So we're starting at the halfway point. Alright. So let's draw a triangle. I'm going to explain this after I draw. Right, so it's the slant distance. It's the slant distance from the centroid of the gate. So I cut the gate in half. It's the slant distance from here to here. So we're trying to find this. This is right. So I cut it in half, and then the surface of the water is right here. Alright, so, and then I know it's 6 feet, right? Because if you split the gate in half, we know that this distance is split in half, so 3 feet. And then you add that extra 3 feet, so 3 feet plus 3 feet is 6 feet. So that's where I'm getting that number. You can tell it's literally the same triangle we already solved for, so I'm not going to do it again. So we know that y slant distance is again 8.485 feet. And so we solve for everything, so we can go ahead and plug in everything we know and solve for this. That's the slant distance. Area moment of inertia is 152.7 feet fourth power. The area of the gate, we solved that. The first step, 25.46 feet. And then the slant distance again. Plug that in your calculator. You get that the slant distance to the center of pressure is 9.192 feet. Okay, so that's good. Before we move on to the next step, we're going to need to know to calculate our moment in the next step. I'm just going to do it right now since we're on the topic. We're going to need to know the difference, the length between the center of pressure and the centroid of the gate. So let's go ahead and do that. We need to find this. So So this is just giving us the distance between the center of pressure and the centroid of the gate. That's all this is. So that's 9.192 feet minus 8.485 feet, and that equals 0.7069 feet. So that's the difference in length, and we're going to use that in the next step. I'm going to do this on the back so we have more room. Okay, so calculate moment about hinge. Okay, so to do this, we have to draw an FBD of the gate, so let's go ahead and do that and make it large. Okay, and then our centroid's in the middle. Center pressure is a little bit below it. Know that the length of the gate, right, we solve for that. We know this is I'm going to write the distance between the centroid of the gate and the center pressure. We just solved for that. That is 0.7069 feet, right? I'll dress. We know this angle is at 45 degrees, right? 45. Yeah. And then we know that the distance from the centroid to the bottom is 3 feet. And then we got to think about we're going to have to solve for this a little bit. So don't worry about that right now. We're going to have to solve for that later. We know that, let's think about the forces acting here. So we know that there's a weight force that actually told us what, I'm going to write this different. It told us the weight of the gate, so it's going to be acting at the centroid, right? And then we know that there's going to be a pressure force that we also solved for, acting at the center of pressure, right? Okay. There's a lot of stuff going on here. Okay. So we need to take a moment about the hinge, right? So I should probably label it. The hinge is right here, right? Okay, so moment about the hinge. So say counterclockwise is positive. So assuming that pressure, which would make sense, right? The water is in this side of the gate. It's going to be pushing that way. That is going to be, pushes that way. It's going to be counterclockwise. So FP is positive, and we need to multiply that by the distance, this x distance, right? That's why I labeled that. The perpendicular distance in this case is x, so we need to multiply by x. Yeah. And then we need to take into account this weight force, so that is pulling down. That is going to be going clockwise, so minus the force of weight, and then we need to multiply that by its perpendicular distance from the hinge, so that will be A in this case. Those are only two forces, so that equals 0. So we're trying to find if the pressure force will be able to hold up this weight. So we need to plug everything in and then see if the force is greater than the weight, is all we're trying to find here, right? So to do that, we're going to have to find if the we're going to have to find x and a, right? So let's find the distances of x and a. X, I'll write it down here. X is going to equal the length of the gate divided by 2 minus the distance between the center. This is the distance between the center of pressure and centroid. So this is I'll explain it. So this is the gate length, right? I divided by 2, so now we're at the centroid length. And then I subtracted the distance between these two, so I'm left with the distance between the hinge and the center of pressure, which is what I want. That's 3.54 feet. So that's what x equals. And then a is the distance between the hinge and the centroid. So if you draw we're going to draw a little triangle for that. So we got the gate, centroid is at this point, right? 45-degree angle. Just drawing a triangle. And we're trying to find A is here. We know that this is 8.48 feet, 485 feet divided by 2. So we can say cosine of 45 degrees. So that's adjacent over hypotenuse. And so rearrange that, we put that in the calculator, we say that A is 3 feet. Okay, so let's plug in the x and a as long as our pressure force and the weight force. Let's rearrange this though a little bit. Okay, so this is the moment of the force, the pressure force, and this is the moment due to the weight of the gate. And remember, this question was just trying to figure out if the gate will fall or not. So we got to figure out if the pressure force will be able to hold up the weight of the gate, basically. And we know that the weight of the gate is 18,000 pounds. So these will not equal each other. So just know that when I plug these in, because one's going to be greater. If it is equal, that means that the gate will hold up, but I'm here to tell you it's not. It's either going to fall or hold up more than it needs to. So let's plug in the pressure force that we found, which was, what was it, 9,532 pounds force, times the x that we found, 3.54 feet. And I'll just leave it like this. We'll say that we'll call this moment of the moment of force by pressure force. And if you put that in a calculator, we will get 33,705. 33,705 pounds force times feet. And then we get, for this, the force of weight is 18,000 pounds, right? 18,000 pounds force times the area, or the, sorry, not area. I labeled it the A length, so the perpendicular distance, which is 3 feet. And we'll call this the moment due to, we'll just call it the moment of the gate for the weight of the gate. And that is 54,000, yeah. So pounds force times feet. So looking at this, we know that the moment of the gate is larger. I don't know why I put that equal sign. Is larger than the moment due to the pressure force. So that means that the gate is heavier than the force applied to the gate. So that means that the gate will fall. So that's your answer. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it in the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.